Hello, and thank you for watching today's video on particle physics. Please visit our website by googling tiokrs. It is tiokrs, the Institute of Knowledge and Research in Science. Today with particle physics we shall begin with the early concepts of atoms and the thoughts and beliefs the pioneering scientists for many years have believed. For many years, people have thought of matter having fundamental elements to it, which they refer to as atoms. In the 19th century, not many chemists believed atoms to exist, even though physicists did. The evidence we had in the 19th century for the atomic theory was something known as bromine gas. If bromine, the gas, was to be diffused into a tube, we realized that if the tube is vacuum, then it can diffuse quicker can fill the tube quicker than if it is full of air. The theory is because that with air, the air molecules collide with the bromine molecules, slowing down the diffusion of the bromine gas. This experiment can also be speeded up by heating the bromine gas, which it is thought that when heating the bromine gas, its molecules have higher kinetic energy and can therefore fill the tube at a quicker rate. Another piece of valuable evidence in the 19th century for the theory of atoms was placing soot into water. You could see the collision between the soot due to the kinetic energy of the water molecules. So now in the 21st century, we know that the atomic theory is a fact, and we have better understanding and knowledge of atoms. Atoms are the building blocks of all matter. The atomic structure consists of what is known as the nucleus, which is the center of the atom. This is the heaviest and densest part of the atom. This is comprised of a proton particle and a neutron particle. The proton and neutrons have similar mass. They are fairly heavy compared to the other particles found in the atom. Another particle in the atom is the electron. It is very light and it orbits the nucleus, so it is out in the edge of the atom. As the electron is on the outskirts of the atom, it is in what I would refer to as quite a vacuum part of the atom. It is mainly empty space, and a lot of the atom's mass is in the nucleus, which I said earlier was very dense. In electrostatic charges, the proton has a positive charge and the neutron has a neutral charge. This means that the nucleus has altogether a positive charge, as the proton is positively charged and the neutron is neutrally charged. The electron, however, has a negative charge. Most atoms have an equal amount of protons and electrons, thus making them neutrally charged atoms. The electron is attracted to the nucleus as particles with opposite charges are attracted to each other, and particles with similar charges are repelled from each other. So two electrons will repel each other, just how two positive protons will repel each other. An electron and proton will attract to each other as they have opposite charges, the electron having negative charge and the proton having positive charge. We shall also look at other things that we look at today. So, what are the other forces within the atom? As we know, in the nucleus there are only the proton and the neutron, which the proton being positive and the neutron being neutral. So what forces cause them to stick together within the nucleus? This force is known as the strong force. It only works at a small scale. The other forces are gravitational force, but that is extremely minute at such atomic levels. The other forces, electromagnetic force, would repel the protons from each other within the nucleus. So it is obvious that at small scale, the strong force is slightly stronger than the electromagnetic force. Now we shall discuss isotopes. Well, with atoms, what determines an atom is the amount of protons it has. The most important thing of an atom that identifies it from other atoms is its proton number, which can also be referred to as the atomic number. Isotopes are atoms with the same proton number but different neutron number. The total amount of protons and neutrons in the nucleus is known as the nuclear number. So we realize with isotopes they have the same proton number but different nuclear number as the neutrons vary. Such an example is carbon-12 is the common form of carbon. It has 12 protons and neutrons together. Its isotopes are carbon-13 and carbon-14. These are carbon atoms with different amounts of neutrons but the same amount of protons. Radioactivity. There are different types of radioactivity. Alpha decay is the release of a helium nucleus, 2 protons and 2 neutrons. Well, radioactivity occurs due to an atom being unstable and it breaking down into smaller atoms and releasing energy of other atoms in the process. This happens as the nucleus of these atoms are fairly large and the electrostatic force overcomes the strong force. So the nucleons within the nucleus, the electrostatic force of the protons pushes the nucleus away and the strong force is not strong enough to keep the nucleons together. Another type of radioactive decay is beta decay, which is an electron being emitted when a neutron decays into a proton, also releasing a neutrino. That is beta minus. Beta plus is the opposite, where a positron is released instead of an electron as a proton decays into a neutron. A positron is the opposite of an electron. It has the same mass but opposite charge. Gamma decay is energy being electromagnetic energy being released. The applications to radioactivity. Yes, there's applications to radioactivity. In the smoke alarm, americium-241 ionizes the air in a small gap. But if a smoke comes in between this gap, then it prevents the current being flowed in this ionized air and it triggers the alarm. We shall also discuss today the photoelectric effect. The photoelectric effect is the look at how light on a surface can absorb light and release electrons. Light is, though it is a wave, it can also be thought of as a particle of matter. This particle is known as the photon. As it collides with an electron on the surface, it is knocked off and the part of the surface is ionized. Ionized is an electron being lost within an atom and it gaining a positive charge. So for an electron to be emitted off the surface from a light ray, the light must have a particular amount of energy known as the work function. This is of the equation E equals hf plus Ek, where Ek is the kinetic energy. So the work function hf, where h is the Planck's constant, an extremely small number, and f is the frequency of light. If a light coming in is above the work function to release the electron, the remaining energy is given to the electron as kinetic energy. And thank you for watching today's brief detail of particle physics. I shall be uploading more on particle physics and other topics in physics, theoretical physics and mathematics and different sciences. A website to obtain more information and detail of such matters is tiokrs. So please Google tiokrs, the Institute of Knowledge and Research in Science. Thank you very much.